Welcome, this is Professor Ridge and today's lesson 9.3, Geometric Sequences. And our first learning objective, find the common ratio for a geometric sequence. A geometric sequence is one in which any term divided by the previous term is constant. This constant is called the common ratio of the sequence. The common ratio can be found by dividing any term in the sequence by the previous term. If a sub 1 is the initial term of the geometric sequence and r is the common ratio, then the sequence will be a sub 1 times r, and then you just keep multiplying by r to get the next term, so times by r again, you get r squared. Then you times by r again, you get r cubed, so on. Okay, so you can think of it recursively. We can just take the previous term and multiply it by r, which is again the common ratio. So let's say our first term is 5, and we want r to be 2. So our sequence is going to be, you start with 5, and then 5 times 2 would be 10. 10 times 2 would be 20. 20 times 2 would be 40. So we're just doubling it every time. 80. So on. So basically this is going to be, if I write it as we have up here, 5 times 2, 5 times 2 squared, 5 times 2 cubed, 5 times 2 to the 4th. Okay, so that's the same thing. Okay, so those are the same sequences. Okay, so how to, given a set of numbers, determine if they represent a geometric sequence. So you have to determine if you have a common ratio, right? So you're going to take each term and divide it by the previous term. Then you compare those quotients to see if they're the same, if it's a common ratio. So if they are the same, a common ratio exists and the sequence is geometric. Okay, so for this first one, let me just write A1, A2, A3, A4. Remember, the subscript tells you what term of the sequence it is. So the first term is 1. So if we want to do, you're going to do A2 minus A1, not minus, divide. Remember, this is how we did with the arithmetic sequence. You subtract to get the common difference. Just a little review there. And if you divide, that would be the common ratio, which is r. So 2 divided by 1 is 2. And then we do A3 divided by A2. So we got to check that it's the same for each one. So A3 would be 4. 4 divided by 2 is 2. So it's looking good. A4 divided by A3 is 8 divided by 4, which is 2. And then A5 divided by A4 is 16 divided by 2. No, 16 divided by 8, which is 2. And so yes. This sequence is geometric, or this is a geometric sequence. And r, the common ratio, is equal to 2. Okay, so that's for A. Now let's look at B. So this is for A. Now let's do B. I'll do it up here. So 48 divided by, so we're going to do 12 divided by, I'm going to use the fraction, divided by 48. So that's 1/4. And then I'm going to do 4 divided by 12. Well, that's 1/3. So I can stop and say no, not geometric. And I can just stop right there. I don't have to check because they all have to be equal. So once I get two that are different, I can stop. So no, that one's not geometric. Okay, our next learning objective, list the terms of a geometric sequence. Okay, example 2, writing the terms geometric sequence, list the first 4 terms of the geometric sequence with a sub 1, or the initial term, equal to 5, and the common ratio r is equal to -2. So the technique, you just write down the first term, a1, then you multiply it by the common ratio to get a2, and then you repeat the process using, so a n is equal to a2 to find a3. I think that should have been a3. I don't know what they're trying to say here. Basically, you're just going to take each term, and to get to the next term, if you can think of it as the recursive thing, you just keep multiplying by 2, right? Whatever r is, you multiply it, multiply it, multiply it until you get as many terms as you want. And then, of course, write the term separated by, that should say commas. I don't know what the book, I'm surprised they didn't catch that. Commas within the brackets. All right, so so the first term is given us is 5, and then we just multiply by 2. So a2 is a1 times r, which is 5 times -2, which is -10. And then a3, you could either do a2, if you want to think of it recursively, times r, or you could do it as a1 times r squared. So this is always going to be 1 less. Okay, so either way, since we're building it, the first 4, I'm gonna do it this way, the recursive way, which I'm sure that's something we're going to talk about in a minute or two. So -10 times 2, times -2, sorry, r is -2. So we get +20. So this will be an alternating sequence. So a sub 4 will be a sub 3 times r, which is 20 times -2, be -40. So our first 4 terms will be 5, -10, 20, -40, so on. Okay, so our recursive, use a recursive formula for a geometric sequence. So that's what I was alluding to in that last example. And that is precisely our next learning objective. Okay, so here's a geometric sequence defined recursively. So the recursive formula for a geometric sequence with the common ratio r and the first term a sub 1 is given by a sub n is r times a sub n minus 1. So you just take the previous term and multiply it by r, okay, for all n greater than 2. So let's try one. Okay, example 3, using recursive formulas for geometric sequences, write a recursive formula for the following geometric sequence. Let's make this a little bigger for you. Okay, so the technique is first figure out the first term, the initial term, a sub 1. Okay, so a sub 1 is 6. Then you find the common ratio by dividing any term by the preceding term. Now, since we're told this geometric sequence, we don't have to check all of them. We just have to take any term, divide it by the previous one. So typically, I just do a2 divided by a1, typically. But you can do any 2 terms. And it's the latter one divided by the one right before it, the previous one. And that reduces to 3/2, or 1.5. So now a sub n is going to be r, which is 3/2, times a sub n minus 1. And that's it. That's a recursive formula for our sequence. And we're done. And the last learning objective, use an explicit formula for a geometric sequence. So the explicit formula for a geometric sequence, the nth term of a geometric sequence is given by the explicit formula a sub n is equal to a sub 1 times r to the n minus 1 power. So remember, you're going to multiply by r to get from the first, if you do recursively to get from the first term, you're given the first term, and then the second term is the first term times r, and then the third term would be the second term, which is times r, which is the first term. A sub 2 is a sub 1 times r. This is a sub 2, a sub 1 times r, and then times the new r. So then if we write that, that's r times r is r squared. So you're always going to be one less than the power you're on. Right? And that's how you get that explicit formula. Okay, so given the sequence, find a sub 2. Ooh, okay, so we're going to plug in 3. Basically, we got to use this formula twice to figure out what r is, and then we can just multiply by r with a sub 1 to get a sub 2. So let's see. A sub 1 is equal to 3 times r to the 1 minus 1, which you can see that's not really going to help us any. Let me get rid of that. So a sub 1 is 3 times r to the 0, which is just 3. Okay. Now if we plug in a sub 4, 24 in the other formula, a sub 4 is a sub 1, which we know is 3. R we don't know. N is 4. 4 minus 1 is 3. And now we're going to substitute 24 in this formula. Okay, divide by 3. So we get 8 equals r cubed. And then we cube root both sides. So hopefully you know the cube root of 8 is 2. Cube root of r cubed. So that's r. So r is 2. And now I can use r2 is a sub 1, which is 3. I'm sorry, a sub 2 is a sub 1 times r to the first power. And r is 2. So that'd be 6. Okay, let's try example 5. Write an explicit formula for the nth term of the following geometric sequence. So write an explicit formula. So we need to know, we know explicit formula a sub n is a sub 1 times r to the n minus 1. Okay, so we want the fifth one. So a sub 5 is a sub 1 times r to the 5 minus 1 would be 4. So we just have to figure out what a sub 1 is and what r is. So we need those two things. Well, a sub 1 is 2. R, we can just, now we're told this is geometric, so again, we don't have to check. We just have to do a2 divided by a1, a sub 2 divided by a sub 1. So the second term divided by the first term would be 10 divided by 2, which would be 5. So a sub 5 is going to be 2 times 5 to the 4th. Okay, so that's the explicit formula for the, oh, they just want us for the nth term. Why was I thinking the fifth term? So a sub n is a sub 1, r, which is 5, and then n minus 1. I don't know why I got the fifth in my head. I must have figured out r real quickly when I was reading it. Okay, this is the answer, not that one. That's just to find the fifth term. Okay, solving application problems, geometric sequences. In real-world scenarios involving geometric sequences, we may need to use an initial term of a sub 0 instead of a sub 1. In these problems, we can alter the explicit formula slightly by using the following formula. So a sub n is a sub 0 times r to the n. Okay, so example 6. In 2013, the number of students in a small school is 284. It is estimated that the student population will increase by 4% per year. So our initial value is 284, and so that would be our a sub 0. And it's going to increase a 1%, 4% per year. So the way we're going to write this is a sub n would be the initial value, 284, times r. Now, it's going to grow by 4%, but you got to remember it's going to be 1 plus 4%. So 1.04. That's our r per n. Okay. So basically, for instance, if I start out with 100 and I say it's going to grow to by 10%, you have to take the 10% times 100, which is 0.10, which is 10, and then so the next year will be 110. Okay, and then from here you're to take 10% of that and add it to it. So you have to actually multiply by 1.04 to get the initial amount. So if you try in a calculator, let me show you here. Or actually, if you look at those two terms and divide it, you'll see that you get r, which is going to be 1.1. So if I did 100, oops, I want to do 110 divided by 100. You see I get 1.1. Okay, so and same thing here. If we're at 284 plus times, let's try that again. 284 times 4%. It's going to grow by that much, but then you got to add back in the 284 to say that next year would be plus 284 would be 295. So the sequence would be 284, 295.36, and then when you divide these two, you see you get 1.04. So you got to take the rate and add it to 1. So 4%, so it's 0.04 plus the 1. Okay? All right, so that's going to be our explicit formula using the modified formula, since we're starting a sub 0 instead of a sub 1. Estimate the population in 2020. So if 0 is 2013, I want 2020. So that would be t equals, and you subtract those. So that would be 7. So a sub 7 would be 284, 1.04 to the 7. And we punch that in our calculator. Okay, so we got 284 times 1.04 to the power 7. So 373.72. And since population, we're going to round it to the nearest whole number. So it's going to be about 374 students. Okay, and that brings us to the end of that section. So make sure you go to the end, practice, practice, practice. Go to the end of the section, do all the odds, and if you feel like it, do some of the even ones as well. All right, have a great day. See you next time.